All right. How are you guys doing? Hopefully doing well. So we're going to talk about a few concepts this week, and this is the first one. Is basically it comes down to how close is close enough, right? We're going to talk about a couple words called precision and accuracy, which you should know, but we kind of use them incorrectly sometimes, and so we want to specify that, and then we're going to talk about something called significant figures later on in a different video. So basically, when we think about it, like when we look at that target, is that good? Is it kind of good? Is it really good? The bullseye is pretty big. The shots are all about there, right? Is that close enough? Well, it's hard to tell. When we look at a graduated cylinder, which you guys have already used, right? Is this close enough? Both situation, it kind of depends, right? It depends what we're trying to do. How close is close enough? So taking a look at, it just depends on the situation. If we were trying to get, to the nearest milliliter, sure, that'd be good enough. If we were trying to get close to, hitting that big red circle in the middle, yeah, sure, that might be close enough. But if we looked at these from different views, maybe it wouldn't be good enough, right? It kind of depends on the situation. Is this close enough? Let me see if I can move myself. So this guy wanted this nice looking unicorn, flying horse, Pegasus thing, and look at what he got on his back. Would you be okay with that? Is that close enough? I mean, it kind of looks like a horse. That's about as good as I could draw. Is that close enough? Right? It depends on the situation. If that was my 5-year-old drawing it, I'd say, yeah, that's dang good. That's about as good as I can do. But, if that is my tattoo artist or somebody in Mr. Winnefeld's class, I'd be like, maybe we need to try again, right? How about this? Is that the right size shoe? Is that close enough, right? That just looks painful. And so that's what we're kind of talking about as we go through here. So what we're really talking about is we're talking about, being Robin Hooding. The difference between this accuracy and precision. So when we look at these three targets, right, we want to say which one's accurate, which one's precise, if they're both or if they're neither. Okay. And so when we look at this, and we're going to get the definitions in a sec, but when we look at this, like, we know this is the goal, right? This is what we want to do. We want to shoot our bow. We want to play darts, right? We want to hit the bullseye as many times as we can over and over and over again, right? This is the goal. And the goal means that you're both accurate and you're precise. Okay. Where if we were this guy, right? This guy means we were precise, but we weren't accurate. This guy is either neither or maybe accurate, but we'd have to take a look at that. We'd have to really look at the data and really look at averages and means and things like that. So obviously we want to be this guy. This guy's not too bad, right? This guy's not too bad because we can make one change, right? If you were this guy and you were throwing darts, you'd be like, all right, I just got to move a little bit down and a little bit to the left. Like literally you could just make a step and keep on throwing the same way and you'd be this guy. Where this guy, basically, you suck, right? You're not good at it. You probably need to practice a lot more or just quit. One of the two, okay? So our goal in everything we do is this, but we're not always there. This isn't bad. This means, all right, practice hopefully is going to make perfect. All right. So taking a look at that, the true definitions are these. So whether you take a look at those pictures or you're writing these down, accuracy is the closeness of a measurement to the true or accepted value, right? So that's the bullseye. I think that's what I have next. It's hitting the bullseye, right? Or it's getting the correct answer, right? That's the other part of it is, you're working up, you're trying to be better and better at this thing called chemistry. And by the time we're done, if you're accurate, it means your score on your test, your quiz, your assignments is going to be really good because you're getting the same thing I would. I am the target, right? I know what the right answer is. I have the right answer, and it's your goal to get there, hitting that bullseye, okay? So that's getting the right answer. Precision is the agreement among a set of numbers, and we'll kind of make that a little bit more obvious. but it's the closeness of the grouping. So if we went back, it's all of your shots in about the same area, right? Now, obviously, we're not playing darts or going hunting with our bow very often. So what we usually use is this. It's an instrument's specific number of digits, right? So there's kind of two different definitions for it. One being, if we get a bunch of data, how close are those numbers to each other? And the second being, all right, depending on our instrument, how specific, how precise is the better word, is that instrument, right? So we're going to take a look at a couple of those things in the next couple slides. So when we take a look at this one, you can see, if my cursor ever gets out of the way, you can kind of see this guy has 1 0, and this guy's got 1 0 and a decimal and 2 digits after that. Which one is more accurate? Which one is more precise? You can actually only answer one of those, right, based on the situation. And the answer is this one is more precise, right? It gives us up to the hundredths. This one, if we're talking about grams or pounds, it only gives us to the nearest. If we were to measure the same thing, this would give us better information than this one would. Okay, we can't even tell accuracy in this case because accuracy is all about knowing or trying to get to the right answer, and we don't even know what we're looking at. We're just looking at the specific number of digits, which is what accuracy and precision, or that's what precision gets us. Okay, so taking a look at this guy, right? Based on what I just said, who's the most precise? Okay, now given the correct situation, we could possibly use both of these, right? But if you were like building my house, I would really, really like if you got down, to the 16th of an inch, right? If you only get to the nearest foot, right, you can be about a half a foot, but what if you come and put my 4 walls together and then all of a sudden there is, this 2-inch gap where the walls don't come together? I don't need little critters coming into my house. Having, missing it by 1/8 of an inch probably isn't a big deal. But if you're off by a whole half of a foot or, a few inches in between there, that's not good. But if we were building, let's say, a road, right, that's miles and miles long, maybe having something within this foot is good enough, right? So again, it comes back to, it's all about the situation we're in and what we need. In chemistry, because we're generally working with really, really small things, we want something that's as fine, as precise as possible. But that's not always the case, depending on the situation. All right, so taking a look at these two, which one is the most precise? And what you're going to find out is even though they look different, they actually have the exact same precision, right? Because every single one of these is a jump of 1. Every single one of these is a jump of 1. They have the same precision. They both go, in this case, probably to the nearest 1 milliliter. And when you look at it initially, it doesn't really look like that. So that's where you got to look at the numbers and really pay attention to what they're saying. Because these look closer together, you're like, most of you probably said, yeah, that guy, he's the most precise. But it's not the case. Okay, and so we're gonna have a rule because we gotta take a look at our meter sticks. We gotta take a look at our graduated cylinders, and that's what we're gonna take a look at next. All right, so our rule. Let me get me out of the way for a second. Our rule for non-digital tools. So if we have a digital tool, all right, our rule is just use whatever is on the digital tool, right? You can't change that. I don't want you to change it. The digital tools are probably about as good as we get. So whether we're using our thermometers or we're using our digital scales, that's going to be good. You can't make estimates. But on both of these, you can. All right. And so the rule is you got to give me every single known digit that is shown to you, plus give me an estimate. Okay, so this is the key. And what it's going to come down to is, depending on the type of instrument you're using, that estimate, that place value, is going to be slightly different, right? So I want you to try to take a look at these two and give me what your best guess is. And I'll put that up and we'll talk about that in class. And we'll go over a bunch of these together, right? So when I'm looking at this one, right, I know it's 35. and I know this is 36, and I know this is 37, right? So I'm looking at this, and this has got to be at least 36, but I can give an estimated guess. And maybe most of you would probably say, 36.5. Perfect. It's about halfway in between. I would have taken 36.6. I would have taken 36.4. I would have taken 36.3. The fact is you're giving me an estimate, right? And this one is a little bit easier to estimate what that is. This one is a little bit harder, even though they're the same scale, right? So this one I'm like 20. That's 25. So this is 24. Maybe this is 24 right on the dot. But if you just told me 24, you would be wrong. You still have to give me that final estimation. So if you want to say 24, it should have been 24.0, right? Versus 23.9, 23.8, 24.1. Any of those would have been fine. But if you just tell me 24, even if it's right on the line, you're actually going to be wrong, which is a little bit weird, right? But this is the key. Make sure you write this down. When you're looking at anything that's non-digital, right? You have to give me that educated guess, even if it's right on the line. Okay, don't forget that. That's one of the things that we'll take a look at as we go on.